Can everyone hear me okay? Great, cool. So let's get started. Feel free to scooch up if you want in the back of the room or, you know, stay in the back of the room. Either way. All right. So this is my talk on the switch as a server. Why should you listen to me? I am Leslie Carr. I'm an operations engineer. I've worked at lots of big websites some of you may have heard of and use all the time. And then about a year ago now, I decided to join Cumulus Networks because I thought they were doing really cool stuff. Cumulus Linux is a Debian-based distribution for network switches. So I'm sure plenty of you know and love Debian, or you might be Red Hat people. And the whole idea is that you should be able to manage your network switch just like you can your servers. Use all of your existing Linux tools to manage your switches. And our current release is based on Wheezy, but we are planning on moving up to Jessie once that is pushed to stable, which should be any day now. We run on Broadcom chipset switches. We have 6 vendors right now, Agama, Dell, EdgeCore, HP, Penguin, and Quanta. The whole idea is that, just like with your servers, right, you don't buy a Red Hat server. You buy a server from whoever, you put Red Hat on it. But switches should be exactly the same thing. And yeah. Now, who here has dealt with the traditionally installing and dealing and configuring switches? Sure, plenty of you, right? It sort of sucks. The traditional process is it comes pre-installed with usually old software, a couple releases behind. They have to telnet sometimes or serial into the box. Telnet, I mean, it's 2015. And you use TFTP to put the new image on, which a lot of times then means, oh great, you have to make a TFTP server. Then you enable SSH. Sometimes you have to use a password. You can't even use a key. Once again, it's 2015. Copy and paste configuration, and then your automation is usually restricted to Perl scripts and expect. So how many of you had to write horrific, painful Perl scripts to deal with this? Yeah, right? And sometimes even like having to have the password to have it pasted manually. It sucks. But, compare that to servers, right? Servers are great. You reboot, the Pixie catches the installer automatically. Sure, TFTP is a boot image over. The new image is pulled over by whichever means you desire. Your post-in scripts run. Then your automation software manages configuration administration. You probably don't even have to log in once. Excuse me. It's all done, right? Which is great. So why can't network gear be like this? We thought. So we wrote Oni. It's a network OS installer, discovery and execution, sort of, it's BIOS, Pixie, Kickstarter, all in one. We use BusyBox, and it has been donated to the Open Compute Project, so anyone can use it, open source. If you go to oni.org, you can see all the documentation, download everything. So the installation process with Oni is much more like a server process, right? It has a discover process, looks for an installer. It will try USB if you have a USB stick plugged into the front of the box, or DHCP, IPv6, neighbor discovery, or it also will try to TFTP to a well-known statically configured address. It will then search for the file name and try to execute that installer. So it will look for starting at oni-installer the hardware, and there's a whole waterfall you can look up on oni.org. As well, it uses a HTTP request, so it sends headers to the web server that include the serial number, MAC address, and some other identifying information. So if you want, you can write some type of server to, depending on your HTTP request, to send a different image out if you so desire, or perhaps a different Kickstart script. Once after the image is fetched, it's then saved and executed on the switch. If you look here are the headers that are sent over after it's been installed, when Cumulus Linux attempts a DHCP over its management interface, it will request option 239. This option is then used to specify a custom provisioning script. We call it zero-touch provisioning. Just think of it, more like a Kickstart script. And here are the headers so that once again you can have some system in place to make a custom kickstart script. The script executes as root, and it does not execute until it sees a cumulus-auto provisioning flag. So you can use any of the following languages. I usually wind up just writing bash scripts because that's the easiest, but Perl, Python, Ruby, don't do Go yet, but maybe. And here's an example of a ZTP script. Also, feel free, if you have any questions, to just stop me at any time. You don't have to wait till the end. You can see here, just your normal bash script, right? Bash, trapping errors, just because I like to see where a script has failed, if it has failed, because I'm lazy and I don't want to have to try to go through line by line, so this will tell you. Just editing the repo, you can see it's a normal apt repo, just like Debian. Installing Puppet, configuring it just to start at boot, and service Puppet restart will then trigger a Puppet run so that the switch will configure on its own. And then you can see exit 0. Exit 0 is also quite important because when if the script has exited successfully on exit 0, then it will set a little flag saying auto provision of successful equals true. So it's basically just like a server OS, right? You get BIOS Pixie, server OS, all the apps, same thing, bootloader and ONI, network OS, and all your apps. Done. And I am going to show you a video on this. It's about 2 minutes. Parts have been sped up just because, we don't want to sit here all day. In reality, the process takes about 10 minutes. And I did a set-x on the ZTP bash script just so we can see what's going on. So here we go, rebooting the system. You can see, looks like just your normal BIOS bootloader. The platform there, it just has a little platform detection that's set in firmware. So it double checks that when you set an ONI installer file, that it is a supported platform, especially because there's PowerPC and x86, and if you try to install one on the other, it will just fail. As you can see, it was DHCPing, requesting the file. You can see right there, it's formatting the hard drive, something everyone is quite familiar with. The ONI installer file actually is basically just a little bash script before the binary. If you unpack any ONI installer file, you'll just see, you see the bash script and then the lovely blob of letters that is the binary. It installs, and there's 2 image slots in all the switches. It's something, server land, you never have a primary and backup, but in network gear, it's a very traditional thing. So if you have a upgrade that goes wrong, you can roll back to the other partition. We just use partitions. So then you also can mount the other partition if you want, just so you can have the file system. There you go. You see it's installed and it's running. And if you see there is the ZTP script. And there you go. Done. Yay. And then I also have it doing a apt-get update and upgrade automatically. So as everyone is used to that, and now done. And I did service Puppet, so I could then show you the next step without Puppet automatically going. Because we're Debian-based, we can do everything via Puppet, users, interface configuration, and routing software. I'm using Quagga in these examples, but you can use Bird, ExaBGP. You could write your own if you really are a glutton for punishment. This will take about a minute. This video will take about a minute. Once again, I've sped it up because many of you have seen Puppet runs, and if you haven't, you can always look on YouTube. They aren't quite as exciting. So there, if you see there, this is sort of the nothing up my sleeve. The routing table just has the default routes. OSPF isn't running. PTM daemon is not running. And there we're starting Puppet. See all of the lovely functions syncing over. Fax, I've actually written a couple of factor facts that are in Factor 2.1, um, just making sure that it correctly detects uh, the software. And I believe Puppet at the time did not have the idea of having so many interfaces because most servers don't have 48 interfaces. Go figure. Uh, yeah, and you see there, Puppet's run. Everything's configured. OSPF is up. Yeah, and all the routes are up. So there you go. Instead of having to cut and paste, you can just be lazy. Start your Puppet run. But then again, not everyone uses Puppet, so I figured I will show you the same thing in Ansible. Um, because Ansible is a push model, I'm running this on 4 switches at once, just because it's pretty easy. Probably should have increased the size of that a bit. Yeah, so once again, you can see on all the switches, nothing is running. They only have the management routes. Don't have any bridges up. And we just have an Ansible playbook, runs it, like gathering facts, configuring some users, installs the license and restarts the main switching process, switchd. It just pushes all of the routes into hardware because you don't want to do all of your routing and switching in software. Configuring PTM, configuring your network interfaces, Quagga, of course. You configure and restart it. Reloading networking. All these things. One thing I love about all configuration management is that it's just as easy to configure one switch as it is to configure 100 switches. Because I think that all of the best sysadmins should be properly lazy at heart. And hey, what's lazier than running a single command? Well, I guess lazier would be having an intern to run the single command. But that's the advanced class. I'll be giving that talk next year. And as you can see, OSPF is running, PTM is running. We have all the routes. And there you go. You just set up your new data center. So, okay, cool. That's pretty cool. But, this is a Debian box. Let's do more. How can we make it even better? So, how many of you have gone to install a new data center or a POP and the connectivity hasn't gotten in yet? It's pretty common, right? And then you're always cursing your project manager, like, why didn't they send me next week? I need my internet. There's no cell signal. We're in a concrete box. So we can make one of these an interim Puppet server. Since this is a switch, which is a specialized piece of hardware, it does have a small hard drive and limiting processing power. So you probably wouldn't want to do this long term. All the switching does take priority. So if the CPU is pegged, it will put off or kill processes that are not switching or routing related. But hey, you got a new rack. You have limited connectivity. There you go. Make it the Puppet Master. Yeah. Oh. Yes.
Is it customizable as far as what gets killed when the CPU is pegged?
Yes, you can customize that in Monet. But I think the switching is hard coded that it always takes priority. So that is not. And if you would prefer to have a Puppet Master take priority, then you should probably just buy a server. But yeah, so here's the topology I'm showing. You can see just 2 switches. We're just having one as the Puppet Master. And this video is going to be about 30 seconds. It took about 2 minutes in reality, but once again, don't want to have to wait all day. So if you see on the left, there's I believe that's the Apache logs for the Puppet Master, and then on the right is the switch. And I'm using PMUX because I like PMUX. Switched from screen a little while ago. So there you go. See it syncing over all the files, sending over lots of information, configuring everything, and done. And then, let's say, all right, you're still in the data center, waiting for your friend to get back. What else can you do? You can have some fun. Look at this. You can play Tetris. And I did speed this video up just to make me look like a better Tetris player. All right, so awesome. We got everything working. Yay, our life is so much easier. That's pretty cool, right? But we're still using, the same tools, and we've made our life pretty good, but I think we can make it even better. So, I'm sure any of you have used Debian, written plenty and Etsy network interfaces. And existing network interface managers are really optimized for desktop and hypervisors, right? For things that only have a couple of interfaces. The complexity increases as your number of interfaces increase and number of VLANs increase. For network interfaces, there's a lot of dependencies, and you must make sure that you have everything in the right order. If you don't, it will fail. It won't tell you why it failed. Just, your bridge might not come up if you haven't already established all of the previous interfaces. There's a lack of support for just doing incremental changes, right? Like in a switch, a lot of times you want to add a VLAN maybe, or a couple other ports, and you don't want to have to bring down all of your networking. On a server, that one port is probably, its only port, so you don't necessarily mind if you have to bring down that interface because you have to make the change. And then there's no tools to query and validate your running interface configurations. So, in switches, right, like you've got a lot of interfaces. You have ports, bridges, bonds, VLANs. There's all these different interface attributes. You have for IP addresses, bridge configuration, spanning tree. I know everyone hates spanning tree, but sometimes it is useful or needed. IGMP. And usually it's a static configuration. You usually aren't using DHCP on your switches. You can, but it's usually not. So, and everyone knows IF up down, what I've just been talking about. It is, uses native Linux tools, very well known. Everyone's been using it forever. It does have excellent documentation, but all configuration knowledge is a burden on the user, right? It doesn't do any checking for you, doesn't understand the idea of subinterfaces. You can have to have incredibly large files if you have a bunch of interface configs, no support for incremental updates, and there are some bugs. So we wrote IF Updown 2. It's a new implementation of IF Updown in Python. It is completely open source, available on GitHub. It's backwards compatible, so you can use your same network interfaces file. It continues to use all of the existing native Linux tools. We didn't want to rewrite any of that. It supports large numbers of interface attributes. We also have Python modules as well that you can interact with for interface configuration if you want to write any of those tools. And my favorite part is we made IF reload, so it acts like a hop instead of a restart, right? Like when you're, like Apache is my favorite example, right? You added a new website, you just want to reload just to get the new site up. You don't want to have to take down everything. So if you want to compare some language, here you go. This is just for one interface to have its subinterface and in a VLAN, and setting its speed. And then in IF up down 2, there's the same configuration. It knows that it makes a little tree, which I actually have right here. So it knows about dependencies that you have to make a subinterface, things like that. There's a bunch of tools built in. It actually will output a .dot file, so you can make nice little pretty graphs like that if you so desire of your network interfaces, and so you don't need to specify subinterfaces and things like that. It also uses Mako templating, which is really useful when you're trying to configure 20 interfaces at once, right? Especially if they're all the same. You can do ranges, you can do lots of more advanced templating, and you also can verify that the template works before you actually load it up. It also does work on servers. We've tested it out on Wheezy, Ubuntu 12.04 and 14.04. And we would love for anyone else testing on their own servers to let us know how it goes. You can find out more on GitHub, IF Up Down 2, PTM, the code that I was using, all of our open source contributions. We have a bunch of kernel patches. We have upstreamed them all, but not all of them have been accepted yet. So you all know, kernel development is not very fast, as it probably shouldn't be very fast, right? You want to make sure everything works well. And I am on Twitter, and I gave this presentation very fast. That is it. All right. So, any questions about this, Linux networking in general?
When you reload the OS, does it interrupt the switch forwarding, or is it still keep going?
So the question was, when you reload the OS, does it interrupt forwarding? Yes, it does. That has been a little bit of an internal debate, but when we do a reload, we decided to make it do, everything just like this, just like a normal server. So that does restart everything. So the question was, when you insert a module like an SFP, is that dependent on the OS, or does the hardware take care of that? Assuming the SFP, there always is a problem. Assuming the SFP does match normal standards, the OS will automatically take care of that. You do have to set, it doesn't do auto detection for 1 versus 10 gig. So if you put a 1 gig module in a 10 gig interface, you have to use ethtool to set the speeds. We've tried with a lot of SFPs, but as everyone knows, there's millions of different kinds, and we haven't been able to get them all. Actually, one of the biggest problems with SFPs is something I'll say, oh yeah, this does match all the standards, and then you'll find out, in its little firmware, it won't actually send all the proper information, or sometimes it'll send it wrong. So there's 2 guys that their entire job is basically just dealing with all the new crazy SFPs we've discovered. Yeah?
Was there ever a discussion about that traditional virtualization layer, so where you would have one virtualization running all the stuff sitting up to it, and then if you need to change configuration, then the other one would fail right over, so that you could reboot to
So the question was, have we thought of virtualization so that if we wanted to reboot one, like having 2 OSs sort of running simultaneously, so if we wanted to reboot one, it would sort of fail over to the hot spare. We had considered some ideas like that. Our biggest thought was actually more like when you're rebooting, just keeping all the power on to the actual switching forwarding layer. But we have not attempted anything like that yet. Trying to go more for just simplicity, just like Linux. Yeah.
Is it primarily layer 2?
Is it primarily layer 2? Nope, we do layer 3. Routing, OSPF, BGP, all of that. I personally like layer 3 networks a bit better, using using the sort of leaf spine topology, just because I've been bitten by spanning tree and loops and things like that in my past plenty, and someone plugging into the wrong port, and then all of a sudden you have a loop, and yeah.
Is there any plans for application aware?
So what do you mean specifically by application aware?
Being able to set specific rules per application.
Okay. No, you can use QoS, but we do not have any per application. Yeah. So you could use QoS, and you could use IP tables to mark something coming from a port as QoS, whatever. Yeah.
So does IP tables operate on the switching hardware at that point, or is it still within the kernel?
So IP tables does operate on the switching hardware. So what we do is we use IP tables, and then then the tool sort of translates it into the Broadcom languages and then pushes that down to hardware. Because, if we had to try to do IP tables at line rate in the CPU, we would need a very powerful CPU.
So follow-up. Does that mean that you can create basically a stateful firewall with it?
Yes, so the Broadcom chipset does have a limited amount of state memory, so I would not recommend a stateful firewall. Stateless, totally, but but there's chipset limitations. So it definitely is not best for a stateful firewall. I get a different specialized hardware for that. All right. Oh, yes.
This is more data center centric. You have working on anything for like campus network? Where 2,000 users connecting to the system satellite?
Well, I mean, it is more data center centric, but you could use it for a campus network. We have 1 gig, 10 gig, and 40 gig. So, yeah. One thing though.
Like security, like port level security and all that stuff.
Yeah, we don't have any special port level security. So yeah, especially if you want to do more advanced features, this would not be the tool. All right, awesome. Yeah. Thank you everyone for showing up. And feel free to find me and ask me any more questions.